I made a couple of these mechanical hummingbirds a year or so ago, and these are a nice project. It will certainly teach you how to use a 3D printer if you're so inclined, but I did not want these running all the time. There's really no sense in it running if nobody's present to enjoy it. These arms here and here are identical. The hole right through here is not used in this model, and the base on this is solid. This is the other bird, and we can see that base is solid down here. And I wanted to put some electronics in here. I also wanted to make this higher, and I wanted to put a PIR, or a motion sensor, in here. So if someone was in the area, they would trigger that motion sensor, and that would turn on the motor. It would run for a predetermined amount of time and then shut down, unless someone was still in the area. And the way this is designed, this motor can be installed on either side. So if you wanted the bird displayed this way, the motor would be out of sight back here. Or you could put the motor on the other side and it would be out of sight if it was displayed this way. So I redesigned this base. Now it's a little bit higher and it's hollow, give room for electronics. And there's a bottom that goes on that base, and it holds an Arduino Nano and a relay, and this is a DC to DC voltage regulator. Now this PIR can be installed in either side depending on which way you want the motor, and you just have to file this corner off to match this slope of this base that goes in there. And I'll show you on the Fusion 360 drawing, there's a hole here and here. The wires from the PIR can go down inside the base on either side. These two wires will loop up to the motor, and there'll be a diode across there. And then the power input is here. Now for this one, the motor will be on this side and the PIR as it's installed. And there will be another drawing that moves this and this hole for the motor to this side. So you can change the orientation of the bird. Just depends on which way you want to build it. I wanted a micro switch down inside this slot. Nothing was utilizing this space. So I wanted a micro switch in there. So when this bird would come forward, I made this little pusher and it goes on there. That depresses that roller on the micro switch. So there's this pusher and there's two 3D printed bolts that hold that in place. Using a standard micro switch as a normally closed and normally open position, we're using the normally closed contacts, and I'm on about version 8 or 9 of this holder for this micro switch. That snaps in there like that, and we're not using this contact. So we run wires from these two pins, and there will be a hole in here, and those wires will go through that hole into the base. And I've actually made one more version of this that has a slot through here, and then there's a plate that goes across that. As you slide that in there, and that plate will keep it from going too far. And that will be in the perfect position for that pusher to come down and operate that micro switch. The initial concept for this was to have a motion sensor, or PIR, that would tell the motor to run for a period of time. Well, then it got a little more complicated than that. You don't really know where the bird's going to stop. I wanted the bird to stop forward. Now, if this just made one cycle, that would be pretty boring. I wanted it to do more than one cycle. But every time this comes forward, it's going to initiate that micro switch. So we have to ignore the micro switch for a period of time, and we call that a spin duration. For this bird, I'm using 60 seconds. This bird will do 1, 2, 3 cycles in about 57, 58 seconds. At 60 seconds, it has satisfied the spin duration, so it comes back one more time, and on the fourth cycle, when it comes forward, when it hits that micro switch, it tells the motor to stop. The next problem we had was this wing was back here. I didn't like the looks of that. I wanted it to park forward. So we have a post-switch delay. So after the motor is told to stop, it's allowed to run, in my case, another 1,750 milliseconds, which brings the wing forward to the parked position. And then if this pusher got out of position or the micro switch broke and there was no input from the micro switch, it was still closed, this thing would just keep running forever. So we then have a safety function, and in my case, it's 45,000 milliseconds or 45 seconds after the spin duration has been satisfied. If there's no input from the micro switch, the bird shuts down in another 45 seconds. Looking at the electronics, we have the PIR, which is the motion sensor. There's 3 wires that lead from it to the Nano. We have 9 volts that come in from our wall transformer. It's 9 volts DC. It comes to the Nano and to the relay. The Nano is not going to be able to handle the current to run that motor, but the Nano has all the programming. So when the motion sensor detects someone in the area, that triggers that section of the program that turns power on to the relay, which supplies power to the DC to DC regulator, and we adjust this little pot here to supply 6 volts to the motor. And these are the wires to the motor, and we have a diode across the motor terminals to prevent a spark or anything that might come back and damage our little computer. And these 2 wires are for the micro switch. The micro switch tells us when the bird is at the end of each cycle. The relay attaches to the base with these 4 screws. The DC to DC regulator fits in between these 2 sides fairly snug, but it's actually held in place with double-sided tape. I've ground a little bit of the plastic away to clear those wires. The Nano, I'm only using 7 pins on the Nano, and I bend those out so I can solder to them. Then I ground the plastic away in these places to clear those pins that are sticking out. The rest of the pins that are facing downward just go into these 2 slots, and it holds that Nano firmly in position. This is the final design for the micro switch holder. It's got that backing plate glued in place, and this little piece sticking out here just gives a little more stability to this. Once we know everything's lined up and we have all the wires installed, and we can put this in here and put a little bit of glue on there. To install that, we just pull those wires down, put that on the holder, and I'm just putting a piece of tape on here, keep those wires in place, and it'll make this fit in there a little more firmly as well. With this pushed down and that plate up against the back of this, that micro switch should be in proper position. I made one more change to the base. I added a push button. This is a normally open momentary contact. And redesigned the bottom of the base, and this has the notches already in it to clear the Nano, and the wires coming off of this DC to DC regulator. Everything else is the same. What the push button does is it puts this to sleep. So if you have a lot of traffic going back and forth in the vicinity of where this is being displayed and you want to turn it off, you just push that button and it will shut this down for whatever amount of time you've put into the sketch. Let's say you put in 6 hours. It'll shut it down for 6 hours. After 6 hours, if something trips the PIR, it'll go and run as it was before. Once again, there's a left and right-hand version of the base and a left and right-hand version of the bottom. With the power supply plugged in, and the PIR will wake up with motion. Push the button, and the bird will stop on its next full cycle. Now I push that button to make it go to sleep. It stopped on the next full cycle. The PIR will not sense anything for 3 hours is what I have this set for. Now if I push this again, but now it'll work on the PIR.